In this question, we have a typical word problem. Where it can get confusing is what unit we are talking about or should assign variables to. Is it specials or nights? Or attendees for that matter? Regardless, we aren't given enough information to express an equation. So let's go to the data statements, evaluating them separately at first. Statement 1 at first blush looks rather close to what the question is asking of us, but it gives the percentage of who booked the two-night passage, not the number, and we don't have the total number of attendees, so statement 1 is insufficient. Statement 2, viewed independently of course, tells us the total number of nights, but nothing about the number of attendees or anything else. By analysis by cases, there could be, say, 132 one-night packages or 66 two-night packages or some other type of case. These cases yield different answers to the question being posed to us, so statement 2 is insufficient. Now we must combine the statements. Since we are dealing in nights in statement 2, let's form an equation for the total number of nights. If n is the number of one-night packages and t is the number of two-night packages, then the number of nights booked is n plus 2t equals 132. Also, translating statement 1 into the language of these new variables, we have t divided by the total, n plus t, equals 0.72. We now have two equations and two variables. From the different nature of the data statements, we can be confident that the two equations are distinct. They are logically dissimilar, though we could confirm it by manipulating the second equation and comparing it to the first. By the n variables n equations rule, we will be able to solve for the variables, so we have sufficient information when the statements are combined. The correct answer is C.